Alright, okay. Let us continue with Newton's second law. Alright, so just for you all to recap, right? So Newton's second law, okay, right, where A, right, the acceleration of the object, okay, the acceleration of the object will be equals to the resultant force, okay, over the mass of the object. Okay, alright, so we take a look, right, at what is the question asking. Okay, a truck A of mass 1000 kg is pulling a trailer of mass 3000 kg. The frictional force on A is 1000 newtons, on B is 2000 newtons, and the truck engine exerts a force of 8000 newtons. Calculate the acceleration of the truck and trailer and the tension T in the tow bar connecting A and B. Okay, so to approach this question, right, we ask ourselves, right, what is the goal of the question? Okay, acceleration of the truck and the trailer. Okay, and then after that the tension. Okay, so the thing is this, right, is the acceleration of the truck and the trailer. We need to ask ourselves, right, are they asking one acceleration or two acceleration? Or put it this way lah, acceleration of the truck and the acceleration of the trailer, are they the same? Okay, think about it. Acceleration of the truck and the acceleration of the trailer, are they the same? Okay. Okay, to answer this question, right, is to ask the other question, and that is, are they being tied together? Okay, so you can see that A and B, right, is being tied by the rope, right? Okay, so they are in a sense connected. Okay, so their acceleration will be the same. So actually we just need to find one acceleration. And then after the second thing to find will be the tension. So you have two things, acceleration and the tension. Okay, so the first one, okay, our very first approach, right, can be that we draw the free body diagram of the individual object. Okay, we draw the free body diagram of the individual object. So firstly, right, we can start with the free body diagram. Okay, free body diagram, right, the short form is also known as FBD, okay, or okay, A. Okay, and then after that what we can do, right, is that we draw the free body diagram. I first have the 8000 newtons, and then after that, right, I have friction or 1000 newtons, 1000 kg, and then after that I have my tension that I do not know. Okay, and then afterwards I have the FBD or object B, right? Okay, and then after that what do I have? I will have, okay, same box. Okay, but you realize the free body diagram is different, right, because the different forces that's acting on it. Okay, I color code it so that you guys can see the different forces better. Now, right, we can see, is there a resultant force? Okay, right, definitely lah, there's a resultant force, which is why they ask you to find the acceleration, right? Okay, so then we can use the Newton's second law, right? So the acceleration is actually equals to F net over, right, the mass of A, right? And then after that you will get 8000 minus 1000 minus T over 1000. Okay, and then you can get 1000 A equals to 7000 minus T. Then for B, okay, for B, right, you also realize you can do the same thing. A is equals to F net on B over the mass of B. And then you get T minus 2000 over 3000. And then what do you have here? What do you have here? You realize that you have two equations. Okay, and therefore I can do simultaneous equation. Okay, right, I can do simultaneous equation. Okay, so let this be equation 1, equation 2. Okay, I like to copy down the equations. Alright, so equation 1 plus equation 2. Okay, so that I will not have any careless mistakes. Okay, so just copy them down. Equals to, okay, so from here, right, okay, what am I trying to do? I'm trying to use elimination methods, right? So then I will take away the negative t. I know t and negative t add up 0 alright, so then this is what I will have. 4,000 A will be equals to what? 7,000 minus 2,000, right? Okay, then this is what I will get. Once I have this, then I can substitute into any of the equations, right? Either equation 1 or equation 2. Okay, so 1,000 times 1.25 will be equal to 7,000 minus t. 7,000 minus t, that will give me 1,250. T will then be equal to 5,750. So I get A, I get T. Right? I get acceleration, I get tension. Okay? Alright? Now, this is what happens when we use the free body diagram of the individual object. Okay? The other method that we can try, right? Okay, is when I see the entire system together. Okay? Alright, so what do I mean by this? Okay? Now, draw another line to separate out. Okay, is that, okay, I'm going to see the whole thing, okay, together. Okay, alright, I copy and paste first so it's easier for you to see. Okay, I look at the, okay, looking at the free body diagram of the whole system. Okay, so what do I mean by the whole system? Okay, it means that I'm looking at this. I'm looking at the whole system, right? So you ask yourself, right, for the system of A and B, what are the forces acting on it? Means that if let's say A and B, right, is considered as only one object, what are the forces acting on it? Okay, you have your 8,000 newtons, you have your 1,000 newton of friction and your 2,000 newton of friction. Then we will ask, right, what happens to the T? You realize that the tension is within the system, and because of Newton's third law, the tension are equal and what? Equal in magnitude, opposite in direction. Equal in magnitude, opposite in direction, so the tension within the system balance each other out. Okay, so this means that I can actually draw, right, okay, this is A plus B, and then after that 8,000 newtons, right, and then after that this is the 2,000 newtons, this is the 1,000 newtons. Alright, and then the tension inside is balanced out. Alright, okay, so then the thing is this, right? A will be equals to F net over mass 8,000 minus 2,000 minus 1,000 over what? Over the mass of A plus B. Okay. And then what do you have? You have 5,000 over 4,000. Then you realize you will get the same thing. And then after that, from there, right, I can, okay, from there I can, okay, sub it back and I can get the tension. So I say that using, then from here, right, using the free body diagram of B, right, the one that we are doing for method, the first method, okay, right, then that's where I can say that T minus 2,000 will be equals to 3,008. Okay, then I use the formula. Okay, so that means that A will be equals to F net over mass. Right, so 1.25 will be equal to T minus 2,000 over 3,000. Right, and then this will be 3750 equal to T minus 2,000. Then T will be equal to 5750 newtons. Okay, alright, okay, so you take a look, alright, take a look and see the thought process, okay, right. So if you guys, right, so this will be what you all will tend to use, alright, means that you can break down your free body diagram into the individual object. Okay, for those of you guys who are able to see that you can also look at the free body diagram of the whole system, okay, then actually this one might also be a alternative method for you. Okay. Okay, then we take a look at practice question 2. Okay, so we have trolley X, trolley Y joined by a stretch spring. Trolley X has twice the mass of Y. When the trolley are released, the acceleration of X is 2 meter per second square to the right. So they draw the free body diagram of trolley X. So the thing is this now, before you even go to the question, you ask yourself, how does it look like? Stretch spring, right? So it's already being stretched. So this means that what, when I release, it will come together. Okay, alright. So then firstly, okay, the free body diagram of X. Okay, right, very quickly. Tension. Okay, and then after that I have a mass that I do not know. Okay, but I know that, okay, for the free body diagram of Y, I will also have the tension, okay, in the opposite direction, and I can say that let the mass, okay, let the mass of Y be M. Okay, if this is M, then this means that your mass of X will be 2M. Okay, so then we recall Newton's second law again, right? So by Newton's second law, okay, A will be equals to what? F net over mass. So A will be equals to T over 2M. Okay, then after that, the thing is that for the free body diagram of Y, right, I can also do A equals to F net over mass. So then A will be equals to T over M. Okay, right, so then after that, T will be equals to AM. Okay, and then for the thing is that I do know that, okay, this A, right, this A over here, okay, this A belongs to X, this A belongs to Y, so I also know that AX will be equals to 2M, so equal to 4M. Okay, what do we have here again? simultaneous equation, right? So then I can say that AYM will be equals to 4M. AY means the acceleration of Y. Okay, so you put the subscript down. Okay, so then the mass balance out, so then this means that AY equals to 4 meter per second square. Okay, alright. And logically it makes sense, right? Because trolley X has twice the mass of trolley Y. So this means that trolley X, right, okay, will move twice as slow as trolley Y. Okay, right? You realize that the acceleration of Y is 2 times the acceleration of X. Okay, and that's because of the difference in mass. Alright, okay, I'll end the video now, okay, so that we can continue with the next one.